There is a machine floating through the void right now, further from Earth than any human-made object has ever been. It left our planet when Jimmy Carter was president, when Star Wars was brand new in theaters, when your parents probably had bell-bottoms in their closets. And here is the thing that keeps me up at night. This machine, Voyager 1, is 15 billion miles from home. 15 billion. And after nearly 50 years of traveling through the freezing vacuum of space, after being bombarded by cosmic radiation, after losing contact with the sun that powers it, this little spacecraft is still talking to us. Still sending data. Still working. How is that even possible? And more importantly, what does it tell us about who we are as a species? Let me take you back to 1977. The world was a different place. The Cold War was at its peak, and the space race had cooled down after the moon landings. But at NASA, a group of scientists realized something incredible. The planets were aligning in a way that only happens once every 175 years. Jupiter, Saturn, Uranus, and Neptune would line up in such a way that a single spacecraft could visit all four of them, using the gravity of each planet to slingshot to the next. This was called the Grand Tour, and the window to launch was closing fast. So they built two spacecraft, Voyager 1 and Voyager 2. These were not massive machines. Each one weighed about 1,700 pounds, roughly the size of a small car. They were powered by plutonium batteries because solar panels would be useless once they got far from the sun. And they were packed with cameras, spectrometers, magnetometers, and other instruments designed to study the outer planets in ways we had never done before. On September 5, 1977, Voyager 1 launched from Cape Canaveral. Its twin, Voyager 2, had actually launched 2 weeks earlier, but Voyager 1 was on a faster trajectory. The mission was supposed to last 5 years. 5 years to visit Jupiter and Saturn, take some pictures, gather some data, and then drift off into the darkness. But something remarkable happened. The spacecraft kept working, and working, and working. When Voyager 1 reached Jupiter in March of 1979, what it sent back changed everything we thought we knew about the giant planet. We had seen Jupiter through telescopes, sure. We knew about the Great Red Spot, that massive storm larger than Earth itself. But Voyager 1 showed us details we had never imagined. It discovered lightning in Jupiter's atmosphere. It found rings around the planet, faint and dark, but definitely there. And most incredibly, it revealed that one of Jupiter's moons, Io, was covered in active volcanoes. This was the first time we had ever seen volcanic activity beyond Earth. Think about that for a second. We sent a machine billions of miles away, and it discovered that a moon we thought was dead and frozen was actually one of the most geologically active places in the solar system. Io has hundreds of volcanoes, spewing sulfur hundreds of miles into space. The images Voyager 1 sent back looked like something from a science fiction movie. Except this was real. But Jupiter was just the beginning. In November of 1980, Voyager 1 reached Saturn. And what it found there was even more breathtaking. We knew Saturn had rings. Everyone knows that. But Voyager 1 showed us that these rings were not simple bands of ice and rock. They were incredibly complex structures, thousands of individual ringlets braided together by the gravity of Saturn's many moons. The spacecraft discovered new moons we had never seen before. It flew close to Titan, Saturn's largest moon, and found a thick atmosphere filled with nitrogen and organic molecules. Scientists realized that Titan might be similar to what Earth was like billions of years ago, before life began. After Saturn, Voyager 1's primary mission was complete. It had done everything it was supposed to do and more. But the spacecraft was still healthy, still functioning, still sending data. So NASA made a decision. Instead of shutting it down, they would let it keep going. They would send it out of the plane of the solar system, up and away from the planets, into the space between the stars. On February 14, 1990, Voyager 1 was about 3.7 billion miles from Earth. NASA decided to do something special. They commanded the spacecraft to turn around and take one last look at home. The camera swiveled, and Voyager 1 took a series of images of the solar system from the outside looking in. In one of those images, Earth appeared as a tiny, barely 1 pixel wide, suspended in a beam of scattered sunlight. Carl Sagan, the astronomer and science communicator who had been part of the Voyager mission from the beginning, called it the pale blue dot. And he wrote something that I think about all the time. He said that everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives on that tiny speck of dust. Every saint and sinner, every young couple in love, every creator and destroyer of civilization, every king and peasant, every mother and father, every hopeful child, every corrupt politician, every superstar, every supreme leader, every hero and coward in human history lived there, on a mote of dust suspended in a sunbeam. That image, that perspective, changes you. It makes you realize how small we are, how fragile our existence is, and how absolutely ridiculous our conflicts and divisions seem when viewed from out there. Voyager 1 gave us that gift, a new way of seeing ourselves. But the spacecraft was not done. It kept traveling, kept moving away from the sun at about 38,000 miles per hour. Every year, it put another 350 million miles between itself and Earth. And incredibly, it kept working. The instruments kept taking measurements. The radio kept transmitting data back home. Engineers at NASA's Jet Propulsion Laboratory in California kept listening, downloading the information, studying it. In August of 2012, 35 years after launch, Voyager 1 crossed a boundary that no human-made object had ever reached before. It entered interstellar space. Not just the edge of the solar system, but the space between the stars. The sun's influence, its magnetic field, and the stream of charged particles it sends out called the solar wind, all of that fades at a certain distance. Beyond that point, you are in the realm of the galaxy itself, in the space between star systems. Voyager 1 crossed that threshold. It became humanity's first interstellar ambassador. And here is what blows my mind. Voyager 1 is now so far away that when it sends a signal back to Earth, traveling at the speed of light, that signal takes more than 22 hours to reach us. Think about that. Light, the fastest thing in the universe, takes nearly a full day to make the journey from Voyager 1 to Earth. The spacecraft is 15 billion miles away and getting farther every single second. So how is it still working? How has this machine, built with 1970s technology, survived for almost half a century in one of the most hostile environments imaginable? The answer is a combination of brilliant engineering, careful planning, and a little bit of luck. First, the power source. Voyager 1 carries 3 radioisotope thermoelectric generators, or RTGs. These are basically nuclear batteries. They use the heat from decaying plutonium to generate electricity. When Voyager 1 launched, these RTGs produced about 470 watts of power. Over time, as the plutonium decays, the power output decreases. Today, nearly 50 years later, the RTGs produce about 220 watts. That is barely enough to run a couple of light bulbs. But it is still enough to keep some of the spacecraft's instruments running and to send data back to Earth. Second, the design. Voyager 1 was built to last. Every component was tested rigorously. The engineers at NASA knew the spacecraft would face extreme temperatures, radiation, micrometeorite impacts, and decades of operation without any maintenance. So they built redundancy into every system. If one component failed, there was a backup. And if that backup failed, there was often another backup. Over the years, various instruments and systems have failed, but the core functions have remained operational. Third, the mission team. There are still engineers and scientists at NASA who work on the Voyager mission every single day. These people are wizards. When a problem arises, and problems do arise when you are dealing with a spacecraft 15 billion miles away, they have to figure out creative solutions. Sometimes they have to write new software for a computer that was designed in the 1970s. Sometimes they have to reactivate thrusters that have not fired in decades. And they do it all with a time delay of more than 44 hours round trip. You send a command, wait 22 hours for it to reach the spacecraft, then wait another 22 hours for the response to come back. Imagine trying to fix a problem with that kind of lag. But they do it. They keep Voyager 1 alive. And as long as the RTGs keep producing power, as long as the spacecraft can still talk to us, the mission will continue. Current estimates suggest that Voyager 1 will have enough power to operate at least some of its instruments until around 2025 or maybe 2030. After that, the power will drop too low, and the spacecraft will go silent. But even then, it will keep moving, keep traveling through the galaxy. A silent testament to human curiosity and ingenuity. Now, let me tell you about something that makes this mission even more profound. Before Voyager 1 launched, a group of scientists led by Carl Sagan decided to include a message. A message for anyone or anything that might find the spacecraft millions of years from now. They created what is called the Golden Record. The Golden Record is a 12-inch gold-plated copper disc, like an old vinyl record. It contains sounds and images selected to portray the diversity of life and culture on Earth. There are greetings in 55 languages, from ancient Akkadian to modern Mandarin. There are sounds of nature, like thunder, wind, birds, whales, and a human heartbeat. There is music from around the world, from Bach and Beethoven to Chuck Berry, and traditional songs from Mexico, Japan, Peru, and many other places. And there are 116 images, encoded in analog form, showing mathematical definitions, the structure of DNA, pictures of humans, landscapes, cities, animals, and even a diagram showing Earth's location in the galaxy. Attached to the record is a cartridge and a needle, along with instructions, etched in symbols, showing how to play it. The cover of the record has diagrams explaining where Earth is relative to 14 pulsars, cosmic lighthouses that could serve as landmarks for any civilization advanced enough to find the spacecraft. The chances of Voyager 1 ever being found by an alien intelligence are almost zero. The galaxy is unimaginably vast. In about 40,000 years, Voyager 1 will pass within about 1.6 light-years of a star called Gliese 445. That might sound close, but 1.6 light-years is still about 9 trillion miles. And even if intelligent beings exist near that star, they would have to detect this tiny, silent spacecraft drifting through the void. The odds are astronomically small. But that is not really the point. The Golden Record was never just for aliens. It was for us. It was a statement about who we are and what we value. At a time when the world was divided by the Cold War, when nuclear annihilation seemed like a real possibility, the Golden Record was a message of hope. It said that despite all our flaws, all our conflicts, we are a species capable of beauty, creativity, love, and wonder. We are a species that wants to reach out, to communicate, to be known. The Golden Record is a declaration that we were here, that we mattered, that we tried. And Voyager 1 carries that message into the cosmos. Long after our sun has burned out, long after Earth is gone, Voyager 1 will still be out there, carrying the sounds of our laughter, our music, our languages, and the image of our pale blue dot suspended in a sunbeam. So what does all of this mean? Why does Voyager 1 matter so much beyond the scientific data and the beautiful images? I think it matters because it represents the best of what we can be. Voyager 1 is a triumph of human cooperation. Thousands of people from different backgrounds, different countries, different fields of expertise, all work together to build these spacecraft and send them on their journey. The mission has outlasted wars, economic crises, changes in government, and the lifetimes of many of the people who built it. And yet, it continues. Voyager 1 reminds us that we are capable of thinking beyond ourselves. The people who designed this mission in the 1970s knew they would probably never live to see it reach interstellar space. They did it anyway because they believed in the value of exploration, of knowledge, of pushing the boundaries of what is possible. That kind of long-term thinking, that willingness to invest in something that will only pay off for future generations, is something we desperately need more of. And on a personal level, Voyager 1 gives me hope. In a world that often feels chaotic and divided, where it is easy to focus on everything that is wrong, Voyager 1 is out there, still working, still sending back data, still exploring. It is a reminder that we are part of something much larger than our daily struggles. We are a species that builds machines to touch the stars. We are a species that looks up at the night sky and asks what is out there. We are a species that sends our music and our love into the infinite. Voyager 1 is 15 billion miles from home, and it is still working, still reaching out. still representing the very best of humanity. And every time I think about it, I feel a sense of awe and gratitude. Gratitude for the people who built it, the people who keep it alive, and the simple fact that we live in a time when this is possible. One day, probably sooner than we would like, Voyager 1 will fall silent. Its power will run out, and it will drift through the galaxy in silence, a message in a bottle floating in an endless cosmic ocean. But even then, it will continue to travel. In about 300,000 years, it will reach the edge of the Oort cloud, the distant sphere of icy bodies that surrounds our solar system. And after that, it will keep going for billions of years, carrying the golden record and our message to the stars. So here is my question for you. If you could add one more thing to the golden record, one more sound, one more image, one more message to represent humanity, what would it be? What would you want an alien intelligence, or even just the distant future, to know about us? Leave your answer in the comments. I want to know what you think, because in a way, we are all part of this mission. We are all part of the story that Voyager 1 is telling, and that story is still being written.